60 years, NASA has been pioneering in aeronautical research. During World War II, the need was for real-time problem solving and responding to a variety of crises associated with American bomber and fighter planes. Today, research is aimed at making planes fly higher, faster, farther, quieter, and with greater safety. Consider the problem of wake vortices, invisible tornado-like patterns of air that trail behind large jets, causing dangerously turbulent conditions for smaller planes following in their wake. The turbulence is so severe that flight controllers must carefully space takeoffs and landings to avoid them. Research on wake vortices has ranged from studies like these at NASA's Flight Research Center in California, where different combinations of gear and flaps are used to break up the vortex, to an experimental laser system at the Marshall Space Flight Center in Huntsville, Alabama. Working with the FAA, the experimental laser program is an effort to develop an accurate wake vortex detection and monitoring system that would permit tracking the path of the vortices produced by large aircraft. Field tested at the John F. Kennedy International Airport in New York, the laser research may one day help make commercial air traffic safer. Information gained by flights of the 2,000-mile-per-hour YF-12 will help the designers of new aircraft and spacecraft. Heating, stability and control, aircraft loads. These are just a few of the many tests underway, using the high-speed planes as flying research tools. The rocket-powered X-24B has completed 36 missions over the California desert near the Flight Research Center, bringing to a close experimental rocket-powered flight tests that began with the XS-1 in 1946. These unique planes have proved extremely valuable in advanced aeronautical research. Using the same aeronautical know-how used to design sleek, high-speed jet planes, NASA engineers are cooperating with the Department of Transportation to test a variety of fuel-saving modifications for large trucks. Even the simple changes have provided a 40% reduction in aerodynamic drag, wind resistance that forces the truck engine to work harder. This translates directly into a highway cruise fuel reduction of 20 to 25%. An interesting ground transportation problem being aided by aeronautical research techniques.
7, 6, 5, 4, 3.
At the Langley Research Center in Hampton, Virginia, they're crashing airplanes on purpose. Engineers hope that these crash-worthiness tests will help designers build lightweight aircraft that can absorb much of the impact energy of a crash, reducing injuries and fatalities. This is a pilot's eye view coming in for a landing, but there's an easier, less expensive way to fly. It's called the Flight Simulator for Advanced Aircraft. What the pilot sees and hears in this simulator at NASA's Ames Research Center is like the real thing. Another advanced research tool for designing and evaluating aircraft performance without ever leaving the ground. That first A in NASA stands for aeronautics, research aimed at improving the quality and safety of flying.